Hello everyone. In our previous videos, we had seen about Call-Pearson's correlation coefficient, which can be done for any numerical values for two variables we had seen. How do we find the correlation coefficient? And we had seen a lot of problems related to those Call-Pearson's correlation coefficient. Now, in some situations, the data may be available in the form of ranks, like it can be about some contest, it can be some examinations, it can be some test scores, it can be flower contest, beauty contest, like that, in which ranks may be assigned to the values. And then if the ranks are assigned, what we can find is called as a rank correlation coefficient. It is done by the mathematician Spearman. So that is why it is called as a Spearman's rank correlation. So here it's said, consider the situation in which the objective is to determine the coefficient of correlation between ranks of students in two different subjects. Such coefficient of correlation is known as Spearman's rank correlation coefficient and denoted by small r suffix capital R. This capital R denotes rank. Small r is nothing but a correlation coefficient, the same notation we are using. Only just to differentiate between Call-Pearson's coefficient and Spearman's rank correlation coefficient, we use this suffix capital R. Generally, it is being used, this particular rank correlation methodology is used for qualitative characteristics. Like, for example, if I want to compare beauty and intelligence, we use this rank correlation. So some more examples wherein rank correlation are used are ranks of selected industries based on earnings per share in 2 consecutive years. I can assign ranks and then use rank correlation. Then preference ratings of similar products by 2 different persons, ranks of employees in 2 different skill sets, and then how 2 different judges are having any alignment or agreement or disagreement. How do we assess that? That also can be possible using rank correlation. So for calculating rank correlation coefficient, there are 2 different formulas. One is if there are ties in the ranks. In the sense, sometimes it may so happen that more than 2 students might have scored in one subject the same marks. So in which case, the rank will be same. You will be having the same rank for those 2. You will be assigning same rank for those 2. How do we do such cases? We will see that also. How do we give a common rank to those 2 or more students who have scored the same marks? So that instance, you call it as there is a tie between ranks. So there are 2 instances possible in rank correlation. One is there may be ties in the ranks. There may not be ties in the ranks. So if there are no ties in the ranks, how do we calculate the rank correlation coefficient? This is the formula we'll be using. R suffix R is equal to 1 minus of 6 times summation di square divided by n into n square minus 1, where n is the number of pairs of data, and this di, we also call it as a deviation. We call this as a deviation. Let me write that. This is also called deviation between ranks. And R suffix X is rank assigned to variable X, rank Y is rank assigned to variable Y. Why we are calling suffix I is there because for each comparison of data, each pair of data, there may be, let us say, n pairs of data. That means the I will take ranging from, I will range from 1 to n. Here I is ranging from 1 to and so on up to n. If there are n pairs of data, then I will take n values, right? Let's proceed. And if there are if there are ties, then how do we calculate? The formula is extended like this: 1 minus of 6 times summation di square plus summation tj the cube minus tj divided by 12. So if you look into the previous formula and this formula, only this portion, means this one wherever I am putting brackets. This portion is an extra term which has come in the numerator. If there are no ties, this entire term will become 0. You will get the previous formula. If I substitute it here as 0, you may notice that it is matching with the previous formula. Right. So what is this Tj? It is nothing but the jth tie length. For example, 3 people would have scored the same marks, in which case tie length is 3. If 2 people have scored the same marks, then the tie length is 2. So here it is explained how many data points are sharing the same rank in each variable. That you call it as tie length. So we will be identifying how many ties are there in each tie, what is the tie length, then accordingly we'll be substituting here in the formula. So this is about your introduction on rank correlation. In our subsequent videos, we will see some problems done on rank correlation coefficient. Till then, take care. See you all in our next video.